Cool.
Yep.
Okay.
Yep.
So my name is Daniel Hambly, and this is my project, Transient Plasticity. So next slide. So to begin, I'll give you a short introduction to the project. So next slide. So Transient Plasticity explores the life cycle of plastic in our current society, providing an architectural response to the global issue of increased environmental plastic pollution through the synthesis of urban infrastructure and the dense fabric of the city. Next slide. The building acts as an organism, metabolizing used plastics through the process of chemical depolymerization before repolymerizing said plastics and developing them into new building materials, forming the canopy roof that covers the inner program. The project is centered around the idea of a building's life cycle, matching that of an organism. The building metabolizes plastic, cleaning the surrounding environment until there is no longer any plastic to be consumed, at which point the outer shell is metabolized, revealing the gardens below. Next slide. So at this point, it's important to ask ourselves why we need this piece of infrastructure. And to do that, we have to go back to the beginning. Next slide. So the project began as I was taking my annual surf trip in Cornwall last summer. I was struck by just how much the levels of plastic had increased in the water from the years prior. I was having to physically move pieces of plastic out of my way, and this immediately began to formulate ideas in my mind for my final project. Upon reading Greenpeace's report titled Upstream Microplastics in UK Rivers, I was struck with the harrowing fact that the UK's River Mersey was the single most polluted river in the world in terms of microplastics. Next slide. So moving forward, it's important to explain the location of the building and why this is significant to the infrastructural element of the project. Next slide. So the building sits within Prince's Dock, situated along the iconic Liverpool waterfront, just a few hundred metres from the Royal Liver building. This site was significant for two reasons. Firstly, sitting directly on the River Mersey draws attention to the devastating effects of microplastic pollution on that very river, while the proximity to the city centre ensures high public engagement. Secondly, the site is directly connected to many of the main recycling centres of the area via water, effectively allowing for the creation of a waterborne plastics delivery network in which all plastics are redirected to the new facility for processing via an electric boat. Next slide. But how does it all work? I will now explain the newly pioneered recycling system that makes it all possible. Next slide. So the project uses a new chemical recycling system pioneered by a French company called Carbios in 2019, in which plastics are combined with specifically engineered enzymes within a bioreactor. The solution undergoes a hydrolysis reaction in which the polymer chains in the plastics are broken down into their base monomers, effectively taking the plastic back to its virgin state. This is a big deal, as returning plastic to its monomer state effectively means it can be recycled infinitely, which has the power to completely revolutionize the plastics recycling industry and therefore the world. Next slide. However, this is only half of the system implemented within the project. Once the plastics have been depolymerized to their base monomers, they are then superheated within the furnace to create a monomer gas. The monomer gas is pumped through the polymer reactor, where it is repolymerized to create a polymer powder. From here, the polymer powder is transported to the extruder, where the powder is gradually heated and extruded through the nozzle to create a virgin plastic filament. Finally, this filament is processed by the on-site workshops, where it is used to fabricate new building elements, thus completing the metabolization process. Next slide. But how does this relate to architecture? And how is metabolism conveyed through architectural theory? Next slide. So through my architectural studies, I've been enamored by the work of the Japanese metabolists who created stunning utopian scenes throughout the 1960s. One of their key theories focused on the idea of metabolic cycles. This was the rejection of the notion that architecture should remain static in time, in favour of an architecture that could continue to grow through the addition and subtraction of replaceable elements. In this respect, the architecture of the metabolists can be divided into two distinct typologies, the permanent and the transient. The theory of metabolic cycles can be understood as a biological metaphor, in which the permanent megastructure forms the main axis or skeleton of the creature. In contrast, the transient elements are built on the scale of man, as a man's life is transient, and the built form on the scale of man must also be transient to reflect this. The transient elements are then interwoven between the permanent elements, creating a cohesive whole with varying life cycles in line with usage. Next slide. This theory is directly translated into my own project through the metabolic process that dictates the building's life cycle. The inner program and systems form the permanent elements, consisting of laboratories, workshops, educational facilities, and a visitor centre, all of which are woven between beautiful tropical gardens. Whereas the transient element of the project is embodied by the roof, acting as an inverted greenhouse, which contains phytoremediative plants that process carbon dioxide and toxins within the air. The life cycle begins at the construction phase, as plastic deliveries provide new plastics to be metabolized and fabricated into the building elements that form the canopy. This process actively removes plastics from the environment, thus mitigating pollution within the Mersey and surrounding area. Next, once the shell is complete, the full effect of the inverted greenhouse comes into play, cleaning the air through phytoremediation. Finally, once the environment begins to show signs of recovery, the outer shell is metabolized back into petrochemicals, replacing the need for virgin feedstock within the petrochemical industry. This metabolization reveals the gardens below, creating beautiful waterfront public spaces for the public to enjoy, thus completing the project's life cycle. Next slide. Finally, I will touch upon the materiality, construction, and programmatic elements that make up the project. Next slide. So the canopy roof is constructed from three components: the superstructure, the biostructure, and the outer shell. The superstructure is the primary structure that supports the roof and is fabricated in modular components within the workshops that fit together like a giant Lego set. The components are 3D printed from a technopolymer called carbon PEEK, in which the PEEK polymer is fortified with 30% carbon fibre, radically improving its tensile strength and thermal resistance. Next, the biostructure acts in tandem as both the secondary structure and the substrate for the phytoremediative plants within the roof canopy. The biostructure is again fabricated in a modular fashion from a modified carbon PEEK with increased porosity to increase its performance as a substrate. Finally, the outer shell is constructed in a modular fashion from translucent PEEK panels, allowing light to permeate the outer shell while providing a thermal and chemical resistant skin for the project. Next slide. Finally, the internal program of the building is split into 7 blocks, which radiate around a visitors centre, acting as the nucleus to the project. Block A contains the enzyme fermentation module, the substrate delivery dock, enzyme laboratories, and public galleries. Block B contains the bioreactors, the raw plastic delivery dock, control rooms, and educational zones. Block C contains the monomer furnace, polymerization reactor, public workshop area, and offices. Block D contains the polymer extrusion module, large-scale fabrication workshops, and material research and development centre. Blocks E and F contain the CAD suites, small-scale plastics workshops, and further offices. And finally, Block G contains the communal canteen and both interior and exterior seating areas. Permeability was a key consideration during the design process, so all blocks are connected through a series of linear walkways that bisect the site across the main accessways and provide a continuous journey through the project that displays both the internal tropical gardens and the machinery that make up the recycling system. Finally, a series of marshland gardens line the perimeter of the project, providing habitats for previously displaced wildlife and acting as the base for tidal turbines that provide much of the energy for the building. So next slide. And if we're in sync, that should be the final slide and the end. So I'll be happy to take anyone's questions.
Well done, you are in sync.
Excellent, excellent. Good stuff.
Okay. So, and you've just 9 minutes, so you did well. I'm going to open up to the judges to ask you some questions. Fire away, cool. Judges. I think I can see Charlie and Mark Kaiser have their hands up. So why don't we start with Mark?
Yeah, so obviously sustainability is great that it's been pushing forwards, and plastic is one of the top sort of byproducts that we all seem to have used willy-nilly and living around. So I get the purpose. A question to you is that if in time the general cohort starts to be more responsible with recycling of plastic, and therefore the input in terms of your waste byproducts reduced, what do you see the lifespan of this building being in terms of going beyond its purpose? If it starts losing its core purpose of trying to recycle and looking beyond there, And therefore, how could the building be repurposed for an alternative use?
So that's a really good question. That was actually kind of the whole idea behind this building, and having the internal gardens and walkways as this kind of, it's as if it acts as if it's a kind of butterfly. So in its initial stages, it kind of exists within this chrysalis. And when we no longer need the plastic anymore, the outer shell becomes metabolized by the inner structures, revealing the gardens below. And we're left with these kind of beautiful public spaces that sit on the riverfront and contain inner programs that can then be repurposed for kind of educational purposes to ensure we never make similar mistakes again, essentially. So that is a very good question. I've been asked that a few times, actually. Yeah, that's
more questions. I think it's a fantastic project, and lucky for you in some ways. I'm actually doing a scheme in Liverpool, so I do have some more, but I'll let some of the judges ask before I ask you another one. That's okay.
Yeah.
John, do you want to ask a question? I saw you got your hand up.
Yeah, I had quite a similar question to Mark, actually, because one of your slides slightly confused me, whether you saw the transition, and I saw that the outer plastic melted away, which I thought was very nice, but I couldn't quite see what was left afterwards apart from some greenery. But very topical that you've chosen Liverpool, given that it's about to lose its UNESCO heritage. And I'd done some work in Liverpool. In fact, I spotted 2 of my buildings at Prince's Dock, which was always interesting. So I thought I'd say, what would you think UNESCO would think of your proposal, given that I don't think Liverpool give 2 hoots about UNESCO and what they do down the docks, and it's quite a radical proposal, if not beautiful. But how do you think that works with what was its heritage status?
So I was anticipating this question after the news yesterday. Essentially, I don't think UNESCO would like it very much. But I think if you take the issue as a whole, if we continue to let these microplastics destroy our environment, there won't be any environment left to enjoy. So this project is almost essential for the kind of continued public enjoyment of these heritage sites. So, and its prime location is really essential for the kind of increased public engagement and to get people really understanding how much of a big deal this is. So yeah, it's it would definitely be a contentious issue, and I can see that being a problem. But yeah, no, I'd be happy to argue with them about it. That's for sure.
Good man, thank you.
Charlie, you've got a question? Hopefully, it's not exactly the same one.
It's not. Daniel, thanks. It's a lovely presentation. I can certainly follow the logic that what's left behind in the future is a park, a multi-level park. So, the suggestion it's like pre-Columbian ruins or something is very attractive, and what's left behind is quite massive and durable. But I'm thinking more about the temporary envelope and the plastic shell that goes over the top. It kind of reminds me of kind of preoccupations of designers like Fry Otto, maybe Buckminster Fuller. So my question is, would you say that your outer envelope is as light and minimal as it could possibly be?
So that is a good question, and the key reason for the kind of oversized envelope making this huge statement is that we're trying to use as much plastic as possible to suck out of the environment, essentially, and use it as this kind of plastic sink. And the kind of plastic sink also works as a carbon sink, because the larger your outer structure, the more space you've got for these phytoremediative plants that kind of inhabit the outer structure. So the greater the effect of the kind of cleaning of the air, essentially, through photosynthesis and phytoremediation. So this kind of large scale outer shell is somewhat justified by those reasons, essentially. It could definitely have been done in a smaller fashion. Kind of one of the ideas of the project was that it would be kind of replicable in different areas of the world along different rivers, and it would perhaps take different forms and different sizes depending on kind of the level of pollution and site-specific requirements in those areas. So yeah, it could be fairly flexible, but in this instance, bigger was better to get as many of the benefits as we possibly could from it.
Now we've had 5 minutes of questions, but I can see Chris has got his hand up. I don't know if Esther and Ash are aware of the hand feature, but do feel free to use if you want to. Chris, go for it.
Yeah, mine kind of segues quite neatly into that, really, which, I mean, firstly, I was pretty horrified when I was looking at through the long list to hear that stat about the River Mersey and how polluted it is on a global scale. I mean, it's appalling. But just, and this is maybe incredibly difficult to quantify, but do you get any sense of, the scale and mass of your building, how that kind of reflects the amount of plastic that's in the water? So, is it, do you get a sense that the quantity of the material that you're proposing here is equivalent to that which needs to be removed? Or, it's a hard one, I appreciate, to probably fully determine, but, if it was just curious to see if that had dictated what you were proposing, and if that relationship had been fully determined, if you like.
So that is a very difficult question, actually. So globally, obviously, plastic pollution within waterways, this is like not even comparable. The Great Pacific Garbage Patch is like the size of a country. It's huge. But we've been specifically dealing with microplastics within the Mersey, which are below 5 millimeters in size. So perhaps in that case, it could be somewhat comparable, but I would still probably assume that this building would be too small, essentially. You might need multiple to draw anywhere near as much plastic out as would need to be, essentially. But yeah, I've never been asked that question before. That's a difficult one to quantify, really. But yeah, I think, yeah, too small. We could do with more, I think.
Great. Any other judges got a question? Now's your time to jump in. You happy? Lovely. Well, thank you very much